Okay, I want to work through some problems in the extra practice problems section to help you prepare. And so you can find that on page 910. And I am not going to do any of the odd problems since you can do those and check your answers to get some practice. Okay, so looking at number 2 on page 910. Okay, this might be the one that was on the mistake. And I think I shifted the book just a little bit. You can see this is bent. I was scanning in the book and I moved it a little bit. It needed to be straightened. And I should have waited. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8 sides. It's an octagon. Doesn't look like an octagon, but it is. All right, we want to find out, since it says find the value of x, we've got to find out how many degrees are in the whole thing first. Okay, so doing that, we would say 8 minus 2 times 180. So that's 6 times 180 is 1080. All right, now we've got to add up all of our sides, remembering that a right angle is 90 degrees. Don't skip that just because it's not a number. That's why they keep putting that in there, by the way. They're trying to snag you on that. All right, so let's start at one place and just work our way around and mark it off as we put it in. 170 plus 90 plus 166 plus 150 plus 143 plus 112 plus 94, okay, equals 925. Sounds about right because our target is 1080. So 925, but just to make sure, we're going to zip through it again really quick. I'm going to change the color on my pen. You can do that too. All right, starting at 170 plus 90 plus 160 plus 150 plus 143 plus 112 plus 94. I got 919 that time. So I better run through it one more time, see if I made a mistake. Okay, this time I'm going to erase everything I wrote on here. $170 plus 90 plus 166 plus 150 plus 143 plus 112. You probably heard the mistake I made. Okay, 925 is what I got in that time. Trying to write with an eraser does not work so well. Okay, equals 1080. Subtract 925 from each side. By the way, if you have 925 up there already, you can just subtract 1080 and then you don't have to actually repunch it in. It'll give you a negative number, but you know it's not negative, so that's all right. All right, and then divide both sides by 5, and you get x equals 31. Then you look at it and you say, 31? There's no way that's 31. Oh, it's 5 times 31. So that would be 5 times 31, or 155. That angle's probably 155. But x is still just 31. Okay? That's how you do internal angles. There is another external angle one there that is even. Remember, for external angles, they equal up to 360. I'm not going to do that one. Okay, this is a good question right here. This is number 4. You know what? This is not what I thought it was. Sorry, this is not on page 910. I so lied about that. I so didn't mean to lie about that. I don't have any idea where this is. Ah, there we go. It's on page, maybe. Nope. Give me a second. We're going to find it. I don't know. I know not. Oh, I know what this is. This is the chapter test at the end. I am so sorry. Okay, the chapter test is on page... Now, I put this in the iPad, and then I can't see where it came from because I always zoom it in as I go along. Okay, this is on page 564. All right, you can use this for extra practice. This is a good question because there are problems like this one on the test. It says, in EFGH, measure of angle F is 40 greater than the measure of angle G. So which one's the smaller angle? You guessed it, it's G. So we're going to make our small angle G so we can imagine this. And, whoops, that doesn't say G, that says 5. Let's do that again. G, okay, and then F, and this is a parallelogram. So it's going to look something like this. E, F, G, H. Okay, and this is 40 greater. So we're going to call G X. And then this would be x plus 40. Okay, so what is the relationship between those two angles? They're consecutive interiors in a set of parallel lines, or they're just consecutive angles on a parallelogram. Okay, consecutive angles on parallelograms are supplementary. So x plus 40 plus x has to equal 180. So we're going to move our 40 over there, we get 140. We're going to combine our two x's, and we get x equals 70 degrees. It says sketch it and label each angle with its correct angle measure. Well, mine looks really bad, so I'm going to make my eraser really small. Well, not really small maybe, but small enough so that we can write in it. Okay, it's really important for you to go back and say, what was I asked to do? Because a lot of your mistakes come there and you lose little piddly points. Alright, so we found that the smaller angle was 70 and the large angle was 70 plus 40, which is 130. 130. 70 plus 40 is 110. Yeah, I can do this. Okay, which together, of course, is 180. Alright, that was a good question because you'll have problems like that on your test. Are you given enough information to determine whether the quadrilateral is a parallelogram? No, you're not. You see, this angle, well, if you just use your, what do you call those, theorem list, you still know it. But if these angles are not across from each other like they look like they are, you know, it could be just a regular quadrilateral. Okay, and it may just be that they're slightly off so that you can't even tell it. Just a little slightly off. So it's not quite so obvious. So no, you can't in number 5. On this one, yes, because these bisect each other, and that's one of the theorems, is that if the diagonals of a quadrilateral bisect each other, it is a parallelogram. And number 7, we don't know on this one because the same sides have to be both congruent and parallel. And I try to give you some idea of how it could be that it would look parallel, but it's not. What if one of these is a little bit shorter than the other? It's just a trapezoid. You can only tell that it's a trapezoid if this line is a little bit shorter than this one. We don't have anything about angles. Ooh, that's not what I meant to say. Yeah, we don't know that these are... Yeah, that can be done because we don't know that these parallel lines, we don't know that the length of them is the same. So it is possible that it would be a trapezoid. Oops. Alright, it says, oh, I wasn't going to do all of them. Oops, I was only going to do number 6. Alright, I'm only doing the even problems. Oh, you don't have any of the answers to these. I just realized that. Okay. All right. If it's equilateral, what could it be? Equilateral means equal sides, so it would be a rhombus or a square. Okay, if the diagonals are congruent, looking at your theorem list, you can see now isosceles trapezoid is not a choice. So they're only asking you about parallelogram, rectangle, rhombus, or square. Now, if you kind of forget and you don't have your theorem list for some reason, if you draw a picture, you can see that those diagonals can't be congruent because this one's going to be longer. This is the short way to go across. Okay? So, more than one way to skin a cat. Why anybody would want to skin a cat is beyond me. So if the diagonals are congruent, it must be a square or a rhombus. Or it could be an isosceles trapezoid, but that's not a choice. Diagonals are congruent, square or rhombus. Not a square or rhombus. Why did you let me say that? You're probably yelling at me. I know. Whoops. Delete. Oh, I didn't want to delete the whole thing. But anyway, a square or a rectangle. Square. Okay. So is a teacher like me, square or a rectangle? At least you won't maybe hate sitting here. Okay. If its interiors angles are all right angles, list each type of quadrilateral for which it is always true. Always true that it has four right angles. Square or rectangle. Those are the only two. Opposite sides are parallel for all of them because they are all parallelograms. So you would list all four. All right, give the most specific name for the quadrilateral and explain your reasoning. Okay, there is no such thing as well, that's not an isosceles trapezoid anyway. Number 14. Okay. We have one set of parallel lines. There are no right angles, and we know nothing about diagonals. We do know we have two congruent sides, but for this to be isosceles, it has to be this side over here that's congruent, because that would give us the congruent bases. So the most specific name we can give this one is just trapezoid. Okay, we're going to do a little bit of work here. 33 plus 57. 33 plus 57 is 90 degrees. So this is 90-degree angle. They expect you to actually do that. All right, since it has diagonals that form perpendicular lines, it's a rhombus. It doesn't matter that the other sides are not labeled. Okay, and if we went on to do more work, we can actually find, yeah, it's a rhombus. It has perpendicular lines. I'm looking to see what else they say about it. Yeah. Okay, number 16. Okay, we know that these are equal. We know that these are equal and this is equal. So by side angle side, we know the two triangles are congruent. See that? This side, these angles, and this side are congruent. So the triangles are congruent. That makes these two sides congruent. And because we have two pairs of consecutive congruent sides, it's kite. Notice you had to follow a train of thought in order to answer that question. Okay, they also used what sounds like they're trying to invoke a theorem, but I'm not sure it's a theorem that they gave us for kites. they comment that a kite, let's see, it has, yeah. They commented that the angle was bisected. Remember, I showed you that when we were doing it in class, that that one set of angles was bisected by the by its diagonal, but that was not a theorem they gave us. So I'm sort of surprised that they're commenting on that. In the book, I'm just checking to see what they have written. All right, in trapezoid WXYZ, the WX is congruent to Y, is parallel to YZ. And YZ is 4.25 centimeters. So WX, YZ, I think it's going to look like this. YZ, YZ. Okay, YZ is 4.25 centimeters long. And the mid segment is 2.75 centimeters long. And then the question is going to be, what is WX? What do you want that? Find WX. Now, using a Laniism, we're going to subtract to find the amount between 4.25. Lanie thought it was really funny that I immortalized her in this way, so now every class will need to know this. All right, the distance between these two is 1.5, and since this number is larger than the mid-segment, that means it has to be getting smaller. So we're going to subtract 1.5 from 2.75. 2.75 minus 1.5, and we get 1.25. That's for those of you who like Lanie's way. Those of you who do not, whoops, okay, we're going to say 4.25 plus x divided by 2 gives us 2.75. Multiply both sides by 2, and we get 550, I'm betting. 2.75 times 2 is 5.5. I was right. That's what I meant. Okay, 4.25 plus x equals 5.5. Subtract and you get 1.25. Then it says the perimeter, oh, this is a different one. Sorry. In RSTU, RS is 3 centimeters shorter than ST. RS TU. Whoops, this is a parallelogram. RS, okay. RS T. Okay, and it says this is 3 centimeters. RS is 3 centimeters shorter. So we're going to call this X, and this is X minus 3, and since it's shorter, we'll draw it shorter. RSTU. Okay, now since it's a parallelogram, they have to be equal, X minus 3 and X. And then it says find RS and ST if the perimeter is 42. So the perimeter is all this stuff added up. So we're going to add together both sides. We're going to say 2x plus 2 times x minus 3 has got to equal 42. Okay, using the distributive property, we get 2x minus 6 here. And then we have 2x over here, so that's 4x is equal to, move your 6 over and get 48. And we have x is 12. So looking at our figure, if this is 12, x minus 3 over here would be 9. Then you're going to double check it, and you're going to say, oh, if both of these is 12, that's 24. Plus, both of those are 9, that's 18. And that is 42. So that is correct. Okay, this is a problem from the book in the rhombus section, so that's an 8.5. This is to do some work to get ready for, let's see, which kinds of tests have this kind of problem in it. if you are going to do either test has a problem like this, sort of. Okay, particularly those of you taking the challenge test, but there's a problem similar to that for both of them. All right, this is the diagonals intersect at E. Given that BAC is 53 degrees and DE is 8, find the indicated measure. Now the easiest way to do this is always to go through and find everything you know. If that's 8, they're going to ask us side lengths, aren't they? They're going to ask us for DB and AC. Okay, so we're going to have to find this length right here. And that's not a problem because you know trig. All right, so since it is a rhombus, this is a right angle. Okay, that's a rhombus. The diagonals of a rhombus form right angles. All right, so we're going to say 53. This is the opposite side. And we're going to do it over the adjacent side because we want to find that side. So that's opposite and adjacent. In so, ka, toa. Opposite and adjacent is tangent. Okay, that's the sides we're using. So we're going to say the tangent of 53 degrees is equal to 8 over x. Now, this is kind of a pain to do. So if you don't like to do it that way, you could say, well, I know that angle. Okay, 90 minus 53 is 37. So you could say, now the x is the opposite side, so you could say tangent 37 is equal to x over 8. That gives you a little bit less work to do. Multiplying both sides by 8, we get x is equal to 8 times tangent 37. So you key it in. I'm using a Casio, so it's 37 tangent. And then don't forget to hit the equals, and we have 6.03 if you take it to the hundredths place. Good job, Danny. She answered the phone for me. And she'll come up here in a few minutes and talk to me. All right, so that means this is about 6.03. Now we're going to look at our instructions and see if that tells us. Did I tell you where this was? I told you it was in 8.5. I was wrong. It's an 8.4. This problem is an 8.4 on page 538. Sorry, I got started and didn't even tell you where it was. Okay. And it says, it doesn't say what to take it to. Normally we take it to the 10th. So we're going to just say it's about 6. Okay, so now we can answer our questions since we know everything. We know everything. No, we don't. What do we not know? We don't know the outside lengths. This is a 3, 4, 5 triangle because it's 6 and 8. Okay, that's 3 times 2 and 4 times 2. And so this is going to be 10. We can work it out. 6 squared plus 8 squared equals c squared. That's 36 plus 64, which is 100. When you take the square root of that, you get 10. So it's 6, 8, 10. And we can answer all the questions because we know everything. Say it with me. We know everything. Okay, D, A, C. All right, we know that the angles are bisected. So we know that it's the same as the angle beside it. So that's 53 degrees. All right, AED. AED is in the center. We know that's a right angle, so it's 90 degrees. ADC. We found this one up here. Well, we found one of them, so 37 twice. 37 twice is 74. And then we know DB is 8 and 8, which is 16. And AE is 6 and 6, which is 12. Whoops, not AE. AE is just 6. And then AC is 12. Okay. Angles of a kite. We know that there are 360 degrees. Let's see, where is this? This is in the kite section, so that's an 8.5.